Hello friends, I am Akanchanan and today I will teach you the first chapter of Physics, Class 6, Chapter 1 Matter. So in this chapter we will learn about matter, its meaning and composition, states of matter, solids, liquids and gases, characteristics of solids, liquids and gases, shape, texture and volume, distinguishing properties of solids, liquid and gases. Matter, its meaning and composition. Definition. Matter is defined as anything which occupies a space and has mass. It can be perceived by our senses of smell, touch, sight, hearing, and taste. Examples: air, water, hydrogen, oxygen, sugar, sand, silver, steel, copper, coal, iron, wood, ice, alcohol, milk, kerosene, petrol, carbon, sulfur, rocks, and minerals are all different kinds of matter because all of them occupy space and have mass. Things like food, clothes, table, chair, human beings, animals, plants, and trees are also examples of matter. Thus, the word matter is used to cover all the substances and materials, living and non-living, of which universe is composed of. The particles of matter called molecules have the following four characteristics. They are very small in size, they have spaces between them, they are in constant random motion, they always attract each other. Number 1. The particles of matter are very small in size. The diameter of water molecule is nearly 1.45 into 10 minus 10 square minus 10 meter. Such a small particle cannot be seen by a microscope. Number 2. The particles of matter have spaces between them. The spacing between particles of matter is called intermolecular space. Take 100 ml of water in a measuring cylinder. Add 20 grams of salt in water gently and stir it well so as to dissolve the salt well in water. It is noticed that the level of water does not change. It shows that the particles of salt have occupied the spaces between particles of water. Here is a figure. The particles of salt occupy the spaces between the particles of water. Number 3. The particles of matter are in constant random motion. The particles of matter are not at rest, but they move randomly in all possible directions in a zigzag path. You might have noticed that in the sunlight coming through a minute opening in a darkened room, the fine dust particles appear to dance in a random and zigzag manner. This is because the air particles surrounding the dust particles are in random motion and the heat the dust particles causing to make them move in a zigzag path as shown in figure 1.2. It is due to random motion of particles of perfume that as it is spread in one corner of a room, it soon spreads throughout the room. Number 4. The particles of matter attract each other. Each particle of matter always attracts other particles in its surroundings. The force of attraction between the constituent particles is called the intermolecular force of attraction. This force keeps the particles of matter together. It is our common experience that around us some substances change into powder, some others change into small crystals, and some do not break easily. The reason is that the magnitude of force of attraction varies from one type of matter to another. Thus, the intermolecular force depends on the nature for each matter of each matter. If the force of attraction between the particles of matter is less, it can easily be broken. But if it is more, it is difficult to break it. Some examples: I. It is easy to move the hand through water, but difficult to move the hand in glycerin. The reason is that the attractive intermolecular forces are more in glycerin than in water. It is easy to break a chalk into pieces but difficult to break a piece of coal. The reason is that the intermolecular forces are less in chalk than a coal. I. Number 3. It is easy to move a body in air that the water because the force of attraction between the air particles is very small and thus the distance between them is more as compared to that between the water particles. In general, the force of attraction between the particles is more in solids, less in liquids, and still less in gases. Conclusion: matter is made up of molecules which are very small in size, 10 square minus 9 meter. The molecules are in constant random motion. They exert a force of attraction amongst each other. They have intermolecular separation between them. Note: a molecule or a cluster of several molecules is called a nanoparticle. States of matter. There are three physical states of matter: solid, liquid, and gas. For example, steel is a solid, oil is a liquid, and oxygen is a gas, while air is a mixture of gases. Water can exist in all the three states, which ice means solid state, water liquid state, and steam gaseous state. The three properties which decide the state of a substance, solid, liquid, or gas, are I. Intermolecular space, force of attraction between the molecules, and 3. Movement of molecules. Solid state. When intermolecular force is very strong, the intermolecular space is negligible and the molecules are not free to move. Matter exists in as a solid. Liquid state. When intermolecular force between the constituent molecules is weak, intermolecular space is more as compared to solids and the molecules are free to move and flow within a limited space. Matter exists as a liquid. Distinction between solids, liquids, and gases. Solids. A solid has a definite shape and a definite size, length, area, and volume. The molecules in a solid are closely packed. Number 3. The molecules in a solid are fixed at their positions. They can only vibrate about their mean positions. The intermolecular forces are very strong. The molecules in a solid are closely packed, therefore solids are highly rigid. Liquids. A liquid has a definite volume but not a definite shape. The molecules in a liquid are loosely packed. The molecules in a liquid can move within a boundary of the liquid. The intermolecular forces are less strong, moderate. Number 5. The molecules in a liquid are less closely packed, therefore liquids are less rigid. Gases. A gas has neither a definite volume nor a definite shape. The molecules in a gas are wide apart. The molecules of a gas can move freely in space. The intermolecular forces are weak. Number 5. The molecules in a gas are least closely packed. Therefore, gases are non-rigid. Gaseous state. When intermolecular force between the constituent molecules is very weak or negligible, intermolecular space is far more as compared to the liquids and the molecules are free to move to and flow anywhere. Matter exists as a gas. Properties of solids. A solid has definite shape and size, length, area and volume. A solid cannot be compressed. Number 3. A solid cannot flow. Number 4. A solid is highly dense. Number 5. A solid has its constituent molecules very closely packed. Number 6. A solid exerts pressure due to its weight only on its base, downwards. A solid has strong intermolecular force of attraction. A solid has a low thermal expansion. It expands a little on heating. Number 9. In a solid, the molecules are not free to move from their positions. They simply vibrate on either side of their mean positions. A solid can have any number of free surfaces. A solid is highly rigid but can be stretched into wires or beaten into sheets. Number 12. A solid does not easily diffuse into other solids. The above mentioned properties of solids can be explained by the molecular model of solid state. Molecular model of solid state. Number 1. There is a strong force of attraction, a strong intermolecular force between the molecules of a solid. Number 2. The molecules in a solid are closely packed. Intermolecular space is negligible. Therefore, solids cannot be compressed much. The molecules are arranged in a definite manner, therefore they have a definite shape. The molecules vibrate on either side of their mean positions, but they do not leave their positions. Therefore, solids have a definite size. The molecules of a solid are arranged in a definite manner. They are packed tightly and so they generally have a high density. Thus, the solids are rigid, they have a definite size and definite shape. Note: a rubber band changes its shape when a force is applied to it, but it returns to its original shape when the force is removed. Thus, rubber is elastic but is treated as a solid. Now, properties of liquids. Liquids have a definite volume but no definite shape because they acquire the shape of the container in which they are kept. Liquids are most incompressible. Number 3. Liquids can flow. Number 4. Liquids are viscous. Each liquid opposes the relative motion between its different layers. Hence, each liquid opposes the motion of an object on it. Liquids have a tendency to occupy minimum surface area. They have surface tension. Due to the property of surface tension, a liquid has a tendency to form a spherical drop. Liquids have only one free surface. A liquid can easily diffuse into other liquids. Number 8. Liquids are less rigid. Number 9. The molecules in a liquid are less closely packed. Number 10. The intermolecular space intermolecular force of attraction is weak in a liquid than in a solid. Number 11. Liquids have high thermal expansion. Liquids expand more on heating than solids. Number 12. The molecules of a liquid are free to move within a boundary of the liquid. Number 13. A liquid exerts pressure in all directions. The above properties of liquids can be explained by the molecular models of liquids. Molecular model of liquids. The attractive force between the molecules of a liquid is not as strong as it is in solids, so they are loosely packed and are not fixed. The molecules can move over one another within the boundary of the liquid. Thus, a liquid has a definite volume but no definite shape. Number 2. The intermolecular space in a liquid is greater than in a solid, so they generally have low density as compared to a solid. They are more compressible. Number 3. The motion of molecules in a liquid is irregular and random within the boundary of the liquid. Thus, liquids do not have a definite shape but have a definite volume and can flow from higher to lower level. They show the property of viscosity and surface tension because the cohesive forces. Cohesive forces. Properties of gases. A gas has neither a definite shape or nor a definite volume. It acquires the shape and volume of its container. Number 2. Gases are highly compressible. Number 3. Gases can flow. They are also viscous but less viscous than liquids. Viscous than liquids. Gases are not rigid. Number 5. A gas diffuses into other gases very fast. Number 6. A gas has no free surface. Number 7. In a gas, the molecules are least closely packed. Number 8. In a gas, there is no force of attraction amongst its molecules. Number 9. The thermal expansion of gases is very large. Number 10. In a gas, the molecules are free to move in a random manner in zigzag paths everywhere. Number 11. Gases do not show the property of surface tension because they do not have free surfaces. Number 12. A gas exerts pressure on the wall of its container from all directions due to the change in momentum on collisions of its molecules with the wall. The above properties of gases can be explained by the molecular model of gases. Molecular model of gases. The molecules of a gas lie much farther apart than they lie in a liquid or a solid. Thus, the density of gases is very low. There is negligible force of attraction between the molecules of a gas, so they are free to move in an entire space available to them. The molecules of gas move much faster than they move in liquids, and therefore they are in fact in a state of incessant random motion, moving in all possible directions and at all possible speeds. Number Distinguishing properties of solids, liquids, and gases. Number 4. The molecules of gas are far apart and there is enough space available for compression. Thus, gases can easily be compressed. During motion, the molecules of a gas collide with one another and also with the wall of the vessel. In each collision, the direction of motion of the molecule changes. So the momentum changes. Number 6. A gas exerts pressure on the wall of its container due to the continuous collisions of its molecules with the wall. Thus, a gas has neither a definite shape nor a definite volume, but it can flow and is easily compressible. Distinguishing properties of solids, liquids, and gases. Properties: mass, solid definite, liquid definite, gases definite. In shape, solids are definite, liquids acquires the shape of the container, gas acquires the shape of the container. Volume is definite, solids definite, liquids also definite, and in gases indefinite acquires the volume available. Compressibility, not in solids, not compressible, in liquids negligibly compressible, and in gases highly compressible. Number 5. Fluidity. In solids it is not possible, in liquids it can flow, and in gases it can flow. Number 6. Rigidity. High rigid, less rigid, and not rigid. Number 7. Diffusion. Solids slow, liquids fast, and gas very fast. Number of free surfaces. Solids any number of free surfaces. Liquids only one free surface, and solid and gases no. Packing of molecules. In solids it is very closely packed, in liquids it is less closely packed, and in gases least closely packed. Number 10. Intermolecular force. Strongest, slightly weaker than in solids, negligible. Number 11. Expansion on heating. In solids it is low, and in liquids it is more than solids, and in gases it is more than liquids. Number 12. Motion of constituent molecules. Solids only vibrate on either side of their mean positions. In liquids, move in all directions but within the liquid, move in a random manner in all space available. Pressure. Pressure on solids only at base downwards at all points, all directions inside the liquid, and in gases on the wall of the container. Number 14. Viscosity. It, in solids, no. Liquids more viscous. In liquids, less viscous. Surface tension. So in liquids, no, and in solids, due to cohesive force tends to occupy minimum surface area, and in gases, no. Changes in state of matter. The change in state of matter of a substance from solid to liquid or from liquid to gas is brought about by imparting heat energy to it at a constant temperature. Number 1. Change from solid state to liquid state. The process of the change of a substance from the solid state into its liquid state on absorption of heat at a particular temperature called the melting point is called melting or fusion. Solids melting liquid heat absorb. Solid melts liquid, solid heat absorb liquid. The heat energy absorbed by the substances increase, increases the amplitude of vibrations of the molecules of the solid, and a stage is reached at the melting point when the molecules acquire sufficient energy to overcome the force of attraction between them, and they become free to move. The solid thus changes into a liquid. Change from solid state to gaseous state. The process of change of a substance from the liquid state to its gaseous state at a particular temperature called the boiling point is called boiling or vaporism bo- or vaporization. Liquid boiling gas, liquid heat absorbed gas. The heat energy absorbed by a substance in liquid state increases the energy of its molecules, due to which they begin to move randomly. Thus, a liquid changes into a gas. List of few liquids, solids, and gases. Solid: ice, aluminium, silver, calcium, gold, iron, salt, sugar, wood, plastic, wax. Liquids: water, benzene, chloroform, oil, honey, glycerin, milk, nitric acid, alcohol, spirit, and Dettol. Gases: steam, air, oxygen, hydrogen, chlorine, nitrogen, ammonia, sulfur dioxide, nitric oxide, helium, and argon. Thanks for watching. Please like, share, and subscribe my video.